I'm Roman Roznik, as you can read. This will be in English, because I don't speak Russian. The topic is clear. What you see are two employers of my heart, like the previous one and the present one. Do you know Seznam.cz? Who knows? And who knows Kiwi.com? Right? Seznam.cz is a very similar company to Yandex. It does have its search engine, maps, yellow pages, whatever. This. Kiwi.com is search and booking engine for flight tickets. I'll be talking about machine learning, about pitfalls of machine learning, and especially in machine learning at startups, or what hell can you feel when you start doing machine learning or data science if you are the first one in the company. Some word cloud will be talking about data features, models, metrics, domain knowledge. And if I'm talking about machine learning, I mean especially like supervised machine learning, that you have data and train something based on the data. And the data that can be turned into some vector of numbers, and quite easy problems of machine learning, not to write a novel based on all the novels that has ever been written. And why I would like to talk about it, because honestly, I don't like the hype of machine learning that is happening in past years, and neural networks and deep learning and whatever. The people say that, okay, with these 30 lines of code, you can solve any problem that you have. And it's not the reality, it's not that easy, or maybe yes, but I have no, I have to pay. I have to go through the hell because I was a bad guy in my previous life, or so. When I enter the Kiwi.com as a first machine learning guy, they showed me the data and told me do the science. And the data were stored in database, and if you are first one who's trying to do something valuable from the data, then you will see that the data are horrible. The prices are in the local currencies, and every single column is string, and if there's a date time, some information, then you know that there's probably a zillion ways how to write the date and time into a string, and you have to convert it somehow. So be prepared that if you'll do machine learning, that this will happen to you. So you have to clean the data, and the data are usually biased. You collect the data that are produced by usually your customers or users, but based on what did your website or whatever offer them. So you cannot have data about some content that you have never sold to the website and never showed to users. One example how data are biased, two guys from China trained the neural network to distinguish between criminals and non-criminals based on their faces. This is the example of criminals and non-criminals from their paper, and they have quite good accuracy, but well, the neural networks, their performance is still very similar to humans. It doesn't outperform as much as being able to distinguish between criminal and non-criminals. And Also, they try to like clean the data and turn it into grayscale and take pictures that looks the same. They still thought that they can distinguish between criminals and non-criminals, and honestly, if you see the data set, maybe it's by the fact that the non-criminals are smiling or have a white roller or whatever. So this example shows that more likely shows that although we try to get rid of bias on our data, we were not able, because still the neural network can distinguish between criminals and non-criminals, which is not possible. So in the data set, there was a feature, like the smile, that highly correlates with the target, whether someone is criminal or non-criminal. And so if I would be like, if someone would like to say if I'm criminal or non-criminal, then based on my smile, or I'd be that or that guy. Nonsense. If you have data, then usually, if you want to do some machine learning, you have to turn the data into features, into vector of numbers. What quite often happens is that there will be some feature that unintentionally correlates with the target you wanna predict, like the smile. Sometimes quite often problem is that you in the features, well, if you want something to predict, like based on this time series data, predict something else, like stock market prices, then I need to drink. Sorry.
It's okay.
So sometimes you, into your data set, get info from the future. For example, if you predict stock market changes, and the neural networks usually want to the feature be somehow normalized, and if you normalized in context on all the data set, then it might happen to you that that in the normalization there still is some information from future. And Michael Ehrlich, some Google guys did this fail, and so be aware that if you are creating a features, then there will be some features from the future. So avoid this. Try to avoid this. And now it comes to model, like neural network, random forest, logistic regression, whatever. If you want to know some Roman numbers, so on the example, you can try some sophisticated neural networks that does it based on the characters. Or you can have a thing and invent the decimal representation of numbers, and it's pretty simple algorithm. So have a thing before you act. So if the problem can be turned into some simple problem, then solve the simple problem. This is usually like the data scientists or machine learning guys loves this the most, like to test several models, play with their metaparameters, the neural network to the architecture of number of hidden layers and whatever. But honestly, this is just very little piece of doing complex data science, and usually it doesn't matter whether the model is that complicated or that simple. They have, at the end, they have a similar performance. And if you introduce more and more complicated model, then, as I said, that the data are usually biased by the smile or whatever, then there is a point, and even if you, of course, you have to split the data into some training and testing set, and both of the training and testing set are biased by the same something. So the more complicated model, at some point the model does not predict what you would like to predict, but start to learn on the bias. So you have to stop, you have to use, it's better to use a simpler model or smaller model, even its performance is a little bit worse than the complex model, because you know that at some point you start to learn the bias. One of my favorite techniques how to show my coworkers that their model is so very complex is to add some number of random features, like generate the features by random. And they build a model, and I usually see that the model does use the random features. Which is wrong. The model should not depend on some randomness. The model just, at the point it used the random features, it means that it did know. Metrics. Usually, if someone gives you a problem to solve, then he told you that this is the metrics we should improve. But that's not only, usually there's not just one bulletproof metrics that is either good or wrong. This is example from Seznam search engine. You see that there is some context advertisement there and there. And like AdWords or AdSense. And how to measure it, whether it's good or bad. You have, well, at least like 5 metrics that you could measure it by. Well, the money that it brings, the conversion rate, like whether the people click or not click, because different ads brings you different amount of money because it's based on bits. You can like CTR stays for click-through rate, whether the user clicks or not click. It's pay-per-click, so. And conversion rate is whether the click is converted, whether someone buys the product or is satisfied with whatever. As well as you need the advertisement to be relevant. This is like non-banking loans query, and the companies that do the loans would like to advertise even on, well, whatever query, because they want people to lend them money. And of course, the presence of the ads is inconvenient to users. So what is the metric of this system? You have to look at all the 5 or all the 6 or whatever. And this is a little bit from Kiwi. Kiwi word. The system how to buy an airplane ticket. There are some websites that the people are used to search for the flights, and there are companies that have the content, and the websites work as proxy of the query to the companies that have the content, like skivi.com. And they send their content, they merge it, show it, and present it like Skyscanner, Kayak, or Momondo. They're the big three. And when the user choose some itinerary and click on it, and usually the websites work like we have to pay for the click. And they click, they look at the booking page, fill the name, surname, whatever, and buy. And what happened to us that our conversion rate was quite small. The people clicked but didn't bought the ticket. And I was told to do something with it, like Roman, you're a scientist, do something with it. And so I took the data about what do people click and what do people really buy, build a model, and the model was good. If it be in production, it would boost the click-through rate like 2 times or whatever. But I look at some other metrics and see that the model don't like expensive tickets. And I told it to my boss, okay, we can boost the conversion rate, but for the price that we lose some sales. And the boss said, no, don't do it. So I was wrong that the bulletproof metric is conversion rate. Improve the conversion rate while don't lose the sales. So I tried harder and built another model, and again observe some other metrics and see that the conversion rate of the tickets that like you are buying like for months or more in advance time is lower. So the model started to dislike the itineraries that flies like month or more in future. So I again came to my boss and told him I can improve conversion rate but we will not sell the tickets that flies in the future, in far future. And okay, that's not possible. Try harder. And I tried harder and harder, and don't see any pitfalls of the model. I'll stop to understand the model. But it was working, so it was in production, and suddenly I somehow invented that the conversion rate of like whole countries, like customers that are grouped by countries, is very different. And it's because of like payment successful rate is different in different countries. So although the people would like to buy it, we don't offer them the way how to pay us. And probably, as the model is so complicated and so many features, then it stopped to predict whether the itinerary is good or bad, but start to predict whether the customer whether we can get money from the customer. But they say, well, it works. It brings us money so far. But what will happen is that as soon as we will be able to charge the customers from the countries where we are not allowed so far, then the model will not give them the content because he was trained that it's bad, and maybe the people that implement the new method of payments will say, okay, it doesn't work, we need to do this and get rid of it, while it's not a good way. So it's the way that if you never know what the machine learning does unless you like deeply go inside and see the interactions between features and so on. It's something that I see in the IT companies is like over-engineering, and the model that I invent to predict whether the itinerary would be bought is kind of over-engineering. We have already fixed it, but it took us another time. Over-engineering. Well, think about that we would produce cars, and somebody, then the car has like square wheels, so it's not good car. And the engineers that do the gearbox change it that the X of the wheels just not rotate about around own X, but do this like kind of movement. So the combination or superposition of this movement and this movement makes the car with square wheels go smoothly. And well, we know it's bad. And well, another boss comes and say, well, the car is slow. So the engineers introduced like better engine, but it weighs 2 times more, and fuel consumption is 4 times bigger. But it's quicker car. And then somebody says, well, okay, it's quicker car, but we have to stop by petrol station each 10 kilometers. So another engineer make the petrol, the place where petrol is bigger, and the car is suddenly it's more heavy than it was, and if the engine is behind rear wheels, and then the gravity center is on the rear wheels, then the car does not like turns because there is no weight on front wheels. So the engineers that makes the car turning add some additional mass of metal to front wheels to fix it. So you are evolving to a monster, and if you go with this car to the production and suddenly someone see that the car does turn right but doesn't turn left, well, of course, because we tested on our circuit that only goes right, and we tell to ourselves, okay, well, needed to go left, like replace going left by 3 times going right, and the car is good. And if you replace any of these bugs with something that works better, then the overall performance gets worse because the bugs are so tightly put together that you have to start to build a new car. Just it cannot fix the bugs and make the car working better. This is example of geocentric or heliocentric way of people see the space. And the car that evolved was something like a geocentric system. We have introduced some special curves that the planets are going on, and when someone came and said, well, put the sun into the center and the planets go around circles, then, well, you have to change the way of thinking. Why? Well, we think that the Earth is in the center, not the sun. It doesn't make sense. And even the heliocentric system was performing worse because for the ages and ages, the prediction of where the planet will be were so good that they outperformed this system just because the planet doesn't go through circles but ellipses. So this is another example of over-engineering. How much time do you have? 30 minutes, okay. Something that is worth to do when you have a problem that is like we want to solve is ceiling analysis. It's from Andrew and machine learning course on Coursera, which is very good. You have a picture, you want to detect and read the labels or the text, and the problem can be split into 3 separate problems, like text detection, where is the text, the character segmentation, to split the text into characters, and the character recognition. And you want the performance of overall system is like 72%, no matter what does it mean. And the question is, which of these 3 like subsystems should be improved to get higher performance? And well, think about this ceiling analysis in your and other problems that you will have. So to find whether we should give more attention to text detection, character segmentation, or character recognition, we can do something like, of course, well, if the text detection would get the best, like we'll have 0 error, how much will the overall performance jump? And the overall performance will jump from 72 to 89, so the jump is by 17%. I mean, if the text detection is perfect, means that you have to have some humans that will mark where the text is. So it needs some human power. And okay, so if the text detection would be perfect, we jump to 89%. What if the character segmentation would be perfect? So again, make the humans to recognize the characters, and instead of your system or your machine learning, whatever, and the performance jumps only by 1%. It means that the character segmentation model works pretty well. And if you have the character, you have to recognize what character it is. And if you, again, make the people to do the character recognition, then the performance of the system jumps by 10%. So the gap between your character recognition software and humans is like 10%. And so you can see that the most the most critical, or where's the biggest gap between your system and the perfect word, is like text detection. So do the engineers do the text detection and not character segmentation? And well, think about this example. I mean, it can be switched to whatever you do. If there is something even worse than over-engineering, then it's A/B testing. A/B testing, we randomly throw a coin whether these users would be A or these users would be B, and serve them different content. It's simple as, well, it's simple. And we A/B test, well, if you go to kiwi.com from Moscow IP, then you will see something like this. On the left side, you can see some like inspiration where to fly. And we A/B tested whether the price should be for one-way ticket, like go only there, or the return ticket. And the A/B test says that the click-through rate is much higher if the prices are just for one-way ticket. So if you click there, you see how to get there and don't see how to get back. And the guy who interpret the A/B test says, okay, higher click-through rate, the better. But from the product, it doesn't make a sense. Well, maybe people from Venezuela or North Korea are more interested in one-way tickets, but people from Russia. This is another example of A/B test. Alza.cz is one of the biggest e-shops in Czech Republic, and this is Tesla car, which costs about it's 8 million rubles, I think, and there is label like in this product, the 10,000 customers is just showing this product, like buy it sooner than it will be sold out, which is completely nonsense. It would mean that like every guy in Czech Republic who can buy it will have opened 20 browsers and looking at this product. But we did as well. On our web page, if you are looking at the ticket or the search results, then there was a banner that says something similar, like 253 customers are interested in this road, like buy it before it will be sold out. And it again improved the click-through rate from the search results to the booking page, but as well the conversion rate from the booking page to like successful payment jumped down. So the overall system was pretty much the same. We just bring more customers to booking page, but from no reason. It's because because they just look at one simple metric, which is click-through rate. People more click, and they somehow expect that if they more click, then the conversion rate would stay the same and boost the sales, which is not true. It's a big pain. Well, more and more like data and statistics and numbers we have, the more people can look at it and do some decisions based on the numbers. But I think that the problem of I think the more and more people understand the numbers and can interpret them well. And as we did some random decisions and did not think that it was so painful for me to see it, then I just like draw to the company like this S pyramid. S stands for approaches to solve stuff. And I explained them that the way of solving problems should go from very bottom to up. When the startup starts, then just all the system is like done on random guesses, and we think that whatever, so that's the bottom of the pyramid. Everybody can make random guesses. And the better approach is to think about it. We are humans, we are equipped with a brain, we can think. And if thinking doesn't help, then like we have some data about our customers, so do some statistics. On the right side you can see, well, the human being that can do it, and intelligence, this is equal, and how much does it cost in terms of money and time. And even if you don't see from the statistic what should you do, then hire the machine learning expert that will do some magic on the data. And the top approach, I think, should be the A/B testing, because, well, you can either, it's so hard to split the users to A or B and to be like representative in A or B. And it's very, very hard to interpret the results, because if you just see about the click-through rate, then don't do it. Yeah, this is my favorite joke. So I'm very like depressive person, and the world is much greener than I showed you here, and even the word in Kiwi is not that bad. The examples were like pushed to absurdity, just to emphasize the problem. So don't think that we at Kiwi are like a bunch of idiots. It's not that way. So the conclusion is, well, don't do machine learning unless it's absolutely necessary. If you do machine learning, then try to understand the black box, what the machine learning really does. Look at the coefficients of linear regression, if it's random forest, print the random forest, see the decisions that it makes. And always look at the data and all the metrics you can imagine, and see your false positives or false negatives, like which, if you do some categorization, like look at the examples that are so wrongly categorized that that's really bad, and if you see how the model works and see how the mistakes it does, then you can reveal the problems that the model does have, like, for example, not selling expensive tickets and whatsoever. Definitely be aware that the machine learning never does what do you think it does. It's just, machine learning is just like, really, it's like a black box. And as I mentioned, I tried to do machine learning on prediction whether itinerary was good or bad, and it ended up in prediction whether the customer is able or not able to pay us. And definitely use your brain. Brain is the most powerful tool you have. It's time. Okay, that's all.
Thank you. Applause. I will break the ideal world a bit and ask the first question myself. Okay, as we can see, the worst pitfall is when we use machine learning, where we actually can skip using it. Am I correct?
Yeah, yeah.
Okay, what is the second worst pitfall you can name if we decide that yes, we want to use machine learning, it really needed in our case, what will be the second most important pitfall we need to be aware of?
Well, I think it was the one I mentioned, that you use the machine learning without using a brain, and don't expect the model, and don't try to find out whether it solves the problem you think it solves. That's the second one from my point of view.
Yeah, modern shamanism is something in machine learning right now. Коллеги, а теперь прошу ваши каверзные вопросы. Кто будет первым? Рита, тебе бежать туда.
Thank you for the presentation, and I would like to jump in the very beginning of your speech. Do you believe in hyperparameter optimization? If we talk about, if we already chosen machine learning algorithm and we need to optimize it, or you believe more in future engineering or something like that? Thank you.
Well, I think better is, like, if I would have to decide whether I would do feature engineering or metaparameter optimization, then I would probably do feature engineering. Don't spend much time of metaparameters optimization, but metaparameter optimization is quite like simple. You can like test them quite easily. Like it just cost a lot, just small time to the programmers, maybe a lot of time of the code is running. It's easy. You can do it, but I think the more important is to have right features.
Коллеги, прошу вас, Рита, по очереди. Сперва коллега в четвертом ряду.
Thank you very much for your speech, and I would like to ask about using staking or bagging technicals. Is it reasonable to spend your time for using, for example, staking of some models, or you would prefer just some simple model instead of it? Thank you.
Like stack of models, you mean that you put many models together and let them...
For example, lasso regression and linear regression, and for example, take average of the outputs.
Yeah, I understand. It's you can have several different models that do the same, like as you mentioned, so I just repeated, like linear regression, random forest, neural networks, and each model says something, and you can make some voting. Well, if 3 of these 4 says it's good, then it's good, or something like that. Usually, the cutting-edge results in machine learning use these like set of models and some voting. But the black side of this, that you have to maintain 4 models and, well, yet another model that makes the votes. And usually the gain that you get by this is not as good as to have one simple model that you understand, and it's maybe a little bit worse. You're welcome.
Okay, thank you for coming. It is not a question, it's my point of view to your speech. I think the technology is not a problem. I think the problem is that technology didn't meet your expectation and doesn't need to do your business. Because as I see, you sell air tickets to customers, and I don't see what you can predict here. As a typical customer, I have flights per year, and I want to see, for example, cheap flight, if I want to, for example, stay in the middle of my itinerary, I want to see a good connecting flight and a good flight that meet my time expectation, and I assume that you have to do better search instead of predict something. What can you say about it?
Yeah, if you go to kiwi.com and search for the flights, then we'll give you all the possible itineraries with long stopovers or whatever, and you can even click that you travel through Europe and stay in each city for some time. You can do it, but on the meta searches that we gave them our results, we have to somehow serve the average customer, and and the customers that have no problem with stay in the city and the stopover for a few hours. These customers are quite rare, and so we do not serve such itineraries to meta searches, because when the people click, we have to pay for the click, but most of the customers doesn't interested in such itineraries. So we pay for this. And very small number of people buy this. So our conversion rate goes down from like looking at the booking page and buying it. And the meta searches things that we offer them like something that the customers do not need. Yeah, there are the customers are very like different, but we have to like more serve to like average customer than all of the customers. That's the problem.
So I assume that you decide which itinerary you have to show to customer.
Yeah, this is the decision. What itinerary?
Okay, I will. Thank you. I will ask you deeper after.
Yeah.
This.
Thank you. Applause. And now you can catch our speaker at coffee break.